dear learners. I welcome you back to this math session. My name is Chamlamko Isaac, Namugongo Secondary and Vocational School. As we were seeing in our previous session, we had reached the examples of the equation of a tangent. And as you can see from our example, we were looking at example 1. We are looking at example 1, where we had the equation to the question wants us to find the equation of a tangent, and the tangent is to the curve y is equal to 3x. It is x cubed minus 3x plus 2. So that is our equation, and they are telling us at a point where x is equal to 2. So they've given us this curve and they want us to find the tangent to the curve. So what we have to do is, I told you, we shall have to differentiate the curve. When we differentiate the curve, we shall get the gradient of the curve. When we get this gradient of the curve, it is the same as the gradient of the tangent. So at the point where this tangent touches the curve, the gradient of the curve is equal to the gradient of the tangent. So you just equate the two, or what you get for the curve is the same as the tangent. Then you will move on to use the equation of a straight line, because we know that our tangent is a straight line. So assuming I sketched for you, this is our sketch, a small x and y axis, and we are saying we have a curve, maybe it is that, and we are saying this is our curve, y is equal to x cubed minus 3x plus 2. And we say we have a tangent. This tangent is touching a curve at a given point where x is 2. So assuming our x is 2 here, then we have this tangent touching the curve at that point. So this is our tangent. So the question wants the equation of this tangent, and as you can see, we say the point where they meet is x is equal to 2, and at that point they have equal gradient. I hope we are together there. So then we can move on now to differentiate the curve. So we shall differentiate the curve, and we say when you differentiate y, we get dy dx. So I can say you're differentiating the curve. Then we differentiate, we get, when you differentiate x cubed, now we know that we shall have 3x squared. Why? The 3 comes in front and the power reduces by 1. So 3 minus 1 will remain with 2. So that's what we get there. Then minus, what is the power here? It is a silent 1. So it will move here and multiply with the 3, and you will end up with 3. Then the x will disappear. Why? Because the power here is a 1. 1 minus 1 is 0. And any number or letter to the power 0 is 1. So this is what we are going to get as our gradient of the curve. But recall that we say the gradient of the curve is equal to the gradient of the tangent. And they have told us that they meet at this point. So at the point x is equal to 2, we shall substitute our value of x in the gradient. When we substitute it there, then we get a definite value for the gradient. So therefore we shall have dy dx being equal to 3 into, where there is x, we substitute with our value for x squared minus 3. And when you compute this very fast, you're going to see that this is a 2 squared, which is a 4. 4 times 3, you get 12. And then 12 minus 3, you remain with 9. So therefore, our dy dx is equal to 9. This implies that since the gradient of the curve is equal to the gradient of the tangent, then the gradient of the tangent, therefore, dy dx also will be 9. Will be 9. So we have this, but the question wants the equation of the tangent. So you recall that in O level we looked at the equation of a straight line. So we can say therefore from, we have the equation of a straight line and we also have the gradient formula, where we say that for us to get the gradient, we can use that gradient is equal to the change in y, in the y-axis, divided by the change in the x what? Axis. So now we have the gradient, and the gradient we are going to use is of the tangent. So it should be 9, but we don't have the value for y because we want to have this formula, and we have x2 minus x1 divided by, I beg your pardon there, it is y2 minus y1 divided by x2 minus x1. So we shall first take note, what is our y2, what is our y1, what is our x2, and what is our x1. The value of x we have here could fall under any category, but when we are calculating, we shall need the value of y, which we have not seen anywhere. So how do we get this value of y? At this particular point, we get the value of x and substitute it in that equation. So if we substitute our value of x in the equation of the curve, we shall have, this is 2 cubed minus 3 into 2 plus 2. Then we shall get our value for y there. So 2 cubed, this is 8 minus 6 plus 2. So if you have 8 minus 6, you get a 2 plus 2, you get a 4. So our y is a 4. And at this point, therefore, the point is the x value we already know is 2, comma, the y value is a 4. So meaning we shall be now having our x and our y. These are the points we are looking for to use in this gradient formula. So in our gradient formula we have the gradient. So this will imply, therefore, that we can continue. The gradient is 9. Then the value of the y2 is the value we don't know, because now we want to find another value on this line, which we can call x, comma, y. This was called, and this will be our x2, y2. This was called our x1, comma, y2. So when you look at this, when you want to find the gradient of the line, we just pick 2 points. Now we already know the beginning point, which is x1 and y1. And then we know the second point, which is x2 and y2. So when you substitute now for these values, x2 and y2 are not known. So we shall leave them as unknowns. So we shall say, where there is y2, we shall leave it as y minus y1. So our y1 here is going to be 4, because we have already said that at that point that was 4. So minus 4 divided by x2 will be x and minus 2. So then we can cross multiply here. Then we shall have y minus 4 is equal to 9x minus 18. So when you simplify that, you will have therefore that y is equal to 9x This is a negative 4. When it crosses the cosine, it becomes a positive. And 18 plus, negative 18 plus 4, you will have a negative 4. 14. So you will have a negative 14. And this will be our equation of the tangent. So you have to be very, very keen when you're calculating. Get the gradient of the curve. It is the same as the tangent, and then use the formula of the gradient. You can also use the formula of equation of a straight line, as we shall see. So let's look at the second example very fast. Let's look at the second example very fast. The second example there is also saying, it is saying, find the equation of the tangent of the curve. Now, we have the curve, y is equal to 4y is equal to x squared. Our curve is x squared at a point, it is 2, the point is 2, 1. We are given a curve and we have a point. Same procedures. We shall first make this x squared divided by 4 for simplicity of differentiating, which is the same as a quarter x squared. Now this a quarter is a constant, so we differentiate. When we differentiate, we shall have dy dx is equal to a quarter, we shall not touch the constant. Then the power moves in front, so it becomes times a 2x, and the 2 reduces by 1, so we get that. So this will give us x divided by 2 as our new function there. So if we have that, this is our gradient. Now at this point, we have that x is 2 and y is 1. So when we substitute therefore, we shall have dy, the x being equal to 2 out of 2, which gives us 1. And therefore the gradient of the curve is 1. Gradient of curve is 1. But we say also gradient of the tangent is going to be equal to a 1. Why? Since they are equal. Since it is equal to gradient of the curve. So since it is equal to the gradient of the curve, it is also the gradient of the tangent. So what next? The other thing is now to find the equation of the tangent. How do we do this? We can say from. Now we are going to use the equation of a straight line, which is y is equal to mx plus c. What do we have? M is our gradient, where m is the gradient, it is equal to 1. X we have, from the point we have that x is 2, and y we have, from the point y is equal to 1. So when we substitute in that equation, we shall have 1 is equal to 1 times 2 plus c. So what shall we get? C is equivalent to 1 minus 2, which is a negative 1. So after that, we substitute. Therefore, our equation of the tangent will be y is equal to m. So m remains because it is our gradient. So it is a 1. So anything times 1 remains. So it will be x plus c, and our c is a negative 1. So that will be our equation of the tangent. So in this case, I've used the equation of a straight line. I've used the equation of a straight line. So we can move on to the next slide and look at what we have prepared there. Now, we are going to look at a normal, and a normal is also a line, and this line is perpendicular to the tangent. Now that we know a tangent, as you can see in our diagram, they've drawn for us a curve, and when this curve at a point, it meets with the line, which is the tangent, and this tangent also has another line perpendicular to it. This line is what we call the normal. Now, the idea I want to develop here is that when you get the gradient of the normal and the gradient of the tangent, you multiply them, you will have a -1. And this is a rule whereby it applies to two perpendicular lines. Now, in this case, in most cases, we have the normal, which is the line perpendicular to any given tangent. So, we can say M1 is the gradient of the tangent and M2 is the gradient of the normal. So, meaning you can get the gradient of either given one scenario. So, if you look at just one example, if you are going to look at the first example there, which is saying find the gradient of the normal to the curve at the point where x equals 1. So, we have that curve, which is y is equal to 4x minus x squared. That is our curve. Same thing, we shall differentiate. At the point where x is equal to 1. So we shall have, we are going to differentiate this curve. When we differentiate this curve, we are going to have 4 minus 2x. When we substitute in our 1, our gradient therefore is going to be 4 minus a 2 times 1, which gives us a 2. So this is the gradient of the curve, remember, and it is also the gradient of the tangent. So, gradient, as we have seen, of the tangent times the gradient of the normal is always equal to a -1, and this is what we are looking at. Now this is our gradient of the curve and tangent, because we say they are equal at that point. Now we are going to just get the gradient of the tangent, which is a 2, times the gradient of the normal. We can call it M1, M2. So we can call this M1 and this M2 is equal to -1, and therefore the gradient M2 of the normal is going to be -1 divided by 2, and that is what we have there. Now, from that we have solved that answer. Lastly, but not least, let's look at this example, and then you will see the assignment I've given you. In the next example, they want us to find the equation of a tangent and the normal to the curve that at that point. So our curve is y is equal to x squared minus 4x plus 1. And they're telling us that this meet at the point -2, 13. Without further ado, the process is the same. We shall differentiate our curve and we shall get 2x minus 4. Now, this is the gradient function, but we need to get the value of the gradient. So we shall substitute dy dx is equal to 2. I told you always substitute the x value minus 4. And here we are going to get -4 minus a 4, which is -8. So you compute this in your calculator. Not always make errors. Now, this is the gradient of the curve and tangent. This is what we've been saying. Now, for us to get the one of the normal, we shall say that from our general equation m1 times m2 is always equal to -1. This will serve as our m1, which is -8 times m2 is equal to negative 1. And then therefore m2 is going to be negative 1 divided by negative 8, which gives us 1 out of 8. So this is now the gradient of the normal. Now we have the gradients of these lines and where they meet, because all of them are meeting at that point. We have that curve, we have the tangent, and we have the normal. So this is our normal, this is our tangent, and this is our curve. All of them are meeting at this point, negative 2, 13. That is a sketch. So if they are all meeting there, they have the same gradient at that point for the curve and tangent, and the negative reciprocal for the normal. So the question wants equations of both our tangent and the normal. What do we do then? We've looked at this. We just use the general equation of a straight line. First, we shall start with the one of the tangent. With the one of the tangent, we know its gradient. So we can say from y is equal to mx plus c. General equation of a straight line. Y is equal to, our y is 13, comma, x is equal to negative 2, and m is equal to, we use the gradient of the tangent, negative 8. So we substitute y is 13 equal to negative 8 into negative 2 plus c. Then you will compute. Negative times a negative gives you a positive. So negative 8 times a negative 2, you get a positive 16. So 13 minus 16 is equal to c. And c will be equal to a negative 3. So we shall substitute it back. So this implies, therefore, that our general equation of the tangent will be y. We write the gradient, we leave it, which is negative 8, so it will be minus 8x minus 3. And this will be the equation of the tangent. Similarly, we are going to get the equation now of the normal. From still the same idea, y is equal to mx plus c, we shall have that our y is equal to 13, x is equal to negative 2. But what changes is the gradient. The gradient of the normal is 1 out of 8. Here it was negative 8. And the process repeats itself. So this will be 13 is equal to 1 out of 8 times negative 2 plus c. And when you compute there, you will have that we have 13 is equal to negative 1 out of 4 plus c. So 13 plus 1 out of 4 gives us c. LCM there is 4. LCM is 4. And 13 times 4, if you don't have a calculator there, you can easily compute that. You will have 12 carry 1, and that is 52. So you shall have 52 plus 1 being equal to c. And therefore our c is equal to 53 out of 4. This implies that our equation is equal to m remains as the fraction of the gradient, x will remain as the letter, plus now our c, which is 53 out of 4. And this is your answer there. This is the equation. This is the equation of the normal. The equation of the normal. So I will implore you, with these examples we've done, to go and do more examples, and the assignment there is given. Please try it out, and I thank you for attending this session. I remain Teacher Isaac, Namgongo Secondary and Vocational School. Go to YouTube, subscribe, and watch our videos. Thank you.